Ah, kids. Okay. I want to continue where we left off from before. So if you guys can get your packets, I believe before we left off on this slide. So we are going to be continuing down here on this slide, which is about magnetic fields. You're definitely also going to want to get your notebooks out because there's some notes that I expect you guys to have that's not in your packet here. So like I said, we're going to be talking about magnetic fields. So let's put this on the board. I just want to make sure you can see this okay. Magnetic fields. Okay. Quick review electric fields. That electric fields, if you guys remember, electric fields point in the direction that a positive charge would move. Stop freaking out. Okay. Sorry, it's going like blurry, not blurry, not blurry, but you know, whatever, deal with it. That electric field points the direction that a positive test charge would move. Where magnetic field, we have to decide, because there's two different poles, does it point in the direction that a north pole moves or a south pole? Well, since we all live in the northern hemisphere, it's going to be the direction of a north pole. So magnetic field points in the direction that a north pole would move. So what we're going to have to do when we're doing this, so let's say, for example, that I have this lovely bar magnet here, north pole there, south pole there, and I ask you guys to find or draw the magnetic field around it. Well, what you're going to do is you're going to pretend, because remember, you can't get a north pole by itself, so we're going to have to put our little pretend caps on, and we're going to pretend we put a north pole right here. If I put a north pole right there and I let that north pole go, it is not, this magnet is stuck in place. It's going to be which way does the north pole go? Well, if I put a north pole there and I let it go, it's going to get repelled by this, so it's going to move that way. Okay, if I put a north pole over here, it's going to get attracted to the south, so it's going to move that way. If I put one here, it's going to kind of go like this, kind of go like that. It would kind of come in here, kind of come in here. Now, if I was to put a north pole here, that north pole is going to start going this way, but then it's going to get attracted to the south. So it's actually going to loop around like this, so that this is what the magnetic field would look like around a bar magnet. The thing that's cool about this is, as you guys saw with the funky demo, with the 3D demos, you can actually see this. So if I take, and sorry if you get you get a little seasick here, but if I take, okay, there we go. I have a bar magnet, and I am going to some iron filings. Okay, you guys can see, at least I think you can see, how the magnetic field loops around like this, it loops around like this, and then up here, it more or less goes straight this way, and then there it goes straight this way. So what I want you to do with your table partners, or your groups, is to draw what the magnetic field would look like around the following two different setups. The first one, let's do, is going to be like this. We're going to have north, south. Let's go north, south, so that the same poles are in the middle. Okay, so north, south, north, south. And then the other one is going to be a horseshoe magnet, and draw what the magnetic field would look like around that horseshoe magnet. So north over here, south over there. Okay. Actually, let me make that a little bit bigger so you can see it. So draw that right now with your table partner. Okay, see you in a second. Bye, kids.